So now we've established these three different methodologies. Let's go ahead for now and just assume we choose the first one. All of them are equally valid, and we'll go through that one first to describe how chapter 1 should be looking for us, okay? So again, now we know with the matter of certainty that our overarching idea is that effectively we're going to start with, again, this is the habit you need to have. I start with a frowning face. We're going to draw it just so that we start on paper to develop the algorithm in this part of the page. And now we've made a big key decision, which is that actually this final picture, I'll draw it on the same color as opposed to before, because before it was a different color because maybe you went with this one, that you created a new smile. We're going to say we're rotate the existing smile, so we'll keep the same color here. Let's pretend they look exactly the same. I haven't drawn them exactly the same. But we've just made the decision that the final port of call before we have this guy is actually a rotate. Now, before we get really, really deep into the lateral thinking exercise of developing the algorithm here, let's just start with version 1 of the algorithm, which is a completely agnostic to any sort of coding language definition of how to do this problem. So if you were going to describe this problem to your CADsman or to some graduate engineer or graduate architect on how to do this problem, what would you do? You'd probably go up to them and say, hey, listen, step number 1 is you have to select the mouth. Okay? We can't do anything. We can't rotate the mouth if we haven't had it selected. So that's got to be step number 1. Step number 2 is you have to type in, let's say, or type the command for rotate. Okay, so if they were doing this with the machine, they'd have to be doing it with rotate. And then really the key is this is a command. It must itself take inputs and outputs. So what are its inputs? And we don't even really need to know what software we're using to know that, again, we talked before, we're talking geometry here. In order to rotate something, what must you need? We must need to know some sort of a number of degrees or radians, yeah? And we probably also need to know a center point for the rotation, yeah? So this is important because now I usually put a little V1 here and I say, this is V1 of the algorithm. Again, we've started very, very high level by saying there's all these different options, just on a very high level of what we could do. We've chosen option number 1 here, and for option number 1, what does that look like just using human language? If we were talking English to the computer, how would it sound? And this is how it would sound. Now the question is it's a question of what does the computer want to hear and what does the computer see? Because the computer, what's imposed on all this is some very basic principles of what a face is. Now, you and I probably all will sit here and have already, without talking about it, understand that what makes a face, the actual object itself, is probably made up of properties that we would label as the outer face, as an outer profile, let's say. Right? We look at this right away and we say those are the eyes. And we say that's the mouth. But a computer, he has no idea what's going on with any of those things. It doesn't make any sense. He's all zeros and ones. So in version 2 of our algorithm, we're going to have to, we draw the same picture, but we're going to start to have some empathy for the machine here. And we're going to put in a little bit of extra information. Not only do I have this guy right here, but he's a DWG, yeah? That's version 1. This file 1 is a DWG file. And not only that is a DWG, but we need to sort of be able to really understand what's in that DWG. So let's first understand what is going on inside this DWG, because in order for us to start to make an algorithm this algorithm here from version 1 into something that's more suitable for the use of a computer, we need to now start mixing and matching these first principles from part 1 with what we actually have digitally down here from version 2.